I want to get our second part of chapter 2, the exploring features of a data, finished today. Essentially, these are the four main things I want to make sure I get covered. There's a lot of stuff in STEM and Leafs that we still to do, showing you what the homework questions look like and how you fill them in. And then after that, there's a big chunk of questions to do with histograms and group frequency tables. So that's kind of the hit list of what I want to get done today. And there's a lot of nuances in a simple thing like a stem and leaf. We talked about it yesterday, and that's fine. Let me sure I don't know where I am. Get distracted there. Where the heck am I? Here we go. Right. You should be looking at question 10 right now. Is that the one you can see on screen? Okay, I can see it. Right. Yep. So, stem and leaf. You've got a set of data, all these red numbers. The fact that red means it's randomized. That means that somebody else doing the same question gets a different group of numbers, so you can't really compare answers easily. And in this stem, that's the 5, 6, 7, 8, 9. Doesn't that represent 50s? That represents the 60s. That represents the 90s. And this is how I would complete this particular stem and leaf. You start at the first one and you go 70 and you put a 4 in and then a space. And then 85, put in a 5 and then a space. 69, put in a 9, hit the space. 94, and it'll take me a while, but I want to do it, at least one of them from start to finish. 88 now, and you put a little space. 93, put in a little space. 55, space. 88. If you hit a space, it means the next time you click on it, it'll be there for you. So that was 88, wasn't it? So next one is 82, space. Almost there. 80, space. 63, 91, 85, and finally 74. So far, so good?
Mr. Robertson, I think
Yes.
you forgot the 81.
I did. Now I'm going to rub out that 81 because I missed it, right? And I'm going to show you what I would typically do because that's exactly what I do. I miss things. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. And then I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. I have missed one. And then I find it and it's 81. Okay, evidently it was that one there I missed, right? So if you count the numbers in your stem and leaf and they don't match how many numbers there are in the data, you've missed somebody and I guess you just have to go hunting for it. Next thing is that that's not finished. What do I still need to do to make that a completed, proper stem and leaf? You notice anything that needs to be fixed?
Not in order.
Yeah, the right order. So that one you turn into a 3 and a 9. Oh, this one's going to take forever and a day, but anyway, you're going to start with a 0, and then you're going to have a 1. So that gets rid of those two guys. And then you'll do a 2. Just gets rid of that guy. And then you get another 5. And that gets rid of that guy. So you can actually do it by just, hitting numbers and deleting. That's 1, 3, 4. That's probably easier just do as 1, 3, 4 than 1, 3, 4. And I think that's it. Agreed? And there's your stem and leaf. So far, so good. Now, underneath it says draw a box plot. Now, we don't do a lot of those, so let me just tell you what's happening here. Do you see these numbers here? 53, 50, 63, 69, all these values. If you draw a straight line like a ruler and you grade it from 50s up to 100, what you're wanting is one of these pictures is this data. So if I use this to help me, there's 150 and it's 55. And I'm looking at it, well, that's not 55, so it's not him. Could be that one. That one's not 55, and this one's not 55. So I guess I've already got the answer. But shouldn't I check, you know, that the next numbers, 63 and 69, does that look like 63? Yeah. Does that look like 69? Do you see each dot represents one of the numbers? So if I was looking at this particular diagram, that dot there would be 91, that would be 93, and that would be 95, and 94, yeah. So there we go, 91, 93, 94. So you've got 4 pictures, and you just pick the right one. Are we happy about creating a stem and leaf based on a list of data? Similar to that question. Now, the next one, if I can find the right guy, is one of those stem and leaves that are doubles. Have you noticed that this has 2 zeros and 2 ones and 2 fours, right? Now, what's happened here is that we have a list of data. That's all these numbers in here. And we are going to take this data and we are going to put it into a stem and leaf, but it's going to be broken into halves. So for instance, these numbers here, the stems, represent hundreds, right? So that's 400 and something, that's 400 and something. And in these ones, you put all the numbers, and I think they explain it here, don't they? Yeah. All the numbers that are 0 and 4 go here, and all the numbers that are 5 to 9 go here, right? Now, if that wasn't bad enough, there's one other thing that you have to take care of. All this data here has to be rounded off to the nearest tens. Because when you do a stem and leaf, the stem is a digit and the leaf is a digit, right? You can only have one number of each. So that means you're going to have to round off your data. Now, some of them I don't need to round off. Would you agree 50 is 50? And that's easy, right? And 100 is 100. But I will have to round off some of the numbers. For instance, I'm going to have to round off 25 to the nearest 10. So what is 25 if you round it off to the nearest 10?
30?
Yeah, 30, right? 5 or above, round it up, okay? We'll use that rule. So here goes, 230. Well, that's 2 and a 3. So 230 gets written down as 23. Right, 2, not 23, but 2 and a 3, right? 230. 2 200s, 3 30. And we don't do it, but they should have had a little key here. You would do this, and you would do a key, and the key, well, let me show you what I'm getting at. Move my fingers in the air and hope that you figure out. In this question, the key to tell people what, you know, all the 2's mean, you would write down something like this. 2 stroke 3 means 230. So when somebody says a 3 there, or a 4 there, or a 7 there, or an 8 there, or an 8A, they know that that 8 actually means 280, right? And that 7 means 270. So that leaf, that's the name you give to it. That 7, the leaf 7, is part of this, so 270. And you see what we mean about the 0, 1, 2, 3, 4s go here, and the 5, 6, 7, 8, 9s go here, right? So far, so good? Right, so let me return back and start filling in, and not all of them, because that would take too long and probably be quite boring to watch as well. Let's fill in just some more, right? The next number is 10. Now, 10 is 0 hundreds and a 1. Does that make sense? That represents 10. 0 hundreds and a 1. The next number is 50. Do I put a 5 here, or do I put a 5 here? The top one or the bottom? Where does the 5 for 50 go? Top or bottom?
The bottom.
Bottom. So we put the 5 here, right? Now the next number is 450. So I've got 450. Do I put the 5 here for 450, or do I put the 5 in the bottom one for 450?
The bottom one.
Bottom one, right? Now, suppose the next number was 470, right? And the next number was 480, right? And the one after that was 420. And the one after that was 440. Do you see where you'd be putting the 2s and the 4s and where you put the 5s and the 7s, right? So that's what the double means. So when you are finished, won't all of these numbers be in your stem and leaf, right? Now, if I had time, which I don't, I would do all of those numbers and, you know, put them in order and make them look pretty. But what I'm going to do instead is just hit key, and it will show us what that answer would look like. It's a great feature that, by the way, you don't have. So I'll rub these out. Now, do you notice the pattern, right? These are all the 10s and 20s and 30s. That 00 one was because one of these numbers was so small. Well, there's one of them, right? Was so small that when you rounded it off, you got a 0. For instance, isn't 4 to the nearest 10 0? Right, so that's why there's 2 zeros. And these are the rest of the numbers. And some of the boxes, these 2 here, didn't have any numbers in them. So we call them, you don't leave them blank, you type in none. That's the instructions, right? Because I don't want you to do a blank there and then hit submit and it'll tell you you're wrong. Really, you're right, but you're wrong as far as WebAssign is concerned, because they wanted you to put none. They want you to you have to show them that you know there's nothing in there. And I would have thought leaving it blank would mean that, but evidently WebAssign's not that clever. You have to physically say, there's nothing in here. And I'm telling you because I'm writing none, right? I guess that's overkill, but that's what they want. Are you comfortable with that? Right. Now, we're going to do something that's hurting my head and probably will hurt your head. Can you imagine taking that guy and turning him sideways so he looks like a histogram? What shape would that histogram be?
It would be a multi-model.
Oh, you could have a couple of bumps in it. I wouldn't argue with that. I'll be more specific. Is it skewed left, skewed right, or symmetric?
Skewed right.
I would say it was skewed right. Would you agree that this has an outlier?
No.
So, okay, you're valid not to agree, but I think there is. I think 450 is an outlier. Would you agree that the last number that we had was 300 and the next number after that was 450? You agree now? Yeah. So that I would count that as an outlier, right?
For sure.
Now, once you turn that on your side and look at it, one of these histograms will look like it. In my picture here, do you see it's that one? Can you see you can tell with the little gap in the skewed rightness looked at? Does that make sense? This would be the histogram if you turned that on its side. Do you see it goes a hill, a little bump, and then tapers off to nothing? Has a hill, there's that multimodal that you were talking about, right? There's a second little bump, and then it levels off. Are we cool with that one? Right, now I'm going to take off the answers because it's very distracting if you can see what the answer is. So the third and final type of stem and leaf for today is a back-to-back stem and leaf. And very often you use them when you're trying to compare two different sets of data. Darn it in space, where is that back-to-back? There it is. Okay. So in question 16, a biology student is studying the effects of two types of nutrient agar, that's the stuff they grow those bacteria in which to promote the growth of it. And they're doing it in a Petri dish. After 2 days, the student counted the number of colonies in each of them. So you've got those little, you know, if you've done the They still do them in biology. And those little plastic trays, and you put some stuff in, and you put a little drop of the green stuff, and you come back, and there's a lot of green stuff, or there's none because it died. That stuff, right? So what you have here is a stem and leaf, right? Oh, there they go. Do you see that little thing I told you about? What does 0, 1 mean, or what does 5/3 mean? Do you see it there? That's the key. Wish they'd done that in all of them. So in this particular group, they've got 2 zeros and 2 1s. So basically, if you were 12, you'd put a 2 here, and if it was 17, you'd put a 7 here. And if it was a 6, you'd put a 6 there. And if it was a 2, you'd put a 2 there. Does that make sense? So let's do A. A is on the left-hand side. That first number is a 6. It belongs here. And the next number is a 5, which also belongs there. And the next number is a 3, which also belongs there. And then we have a 13. Does a 13 belong in the top box or the bottom box? Where does 13 go?
Top box.
Yeah, anything from 0 to 4 goes in the top box. So where are we going? 13 goes here. And can you imagine I did all of them, right, in the same way? Let me now show you what the completed picture would look like for my set of data. And then we can do a compare and contrast kind of thing. So I'll just go up a bit further. I'll hit the key and let's see what it looks like. There we go. Now, there's a couple of little idiosyncrasies that you've got to live with when you do a back-to-back. On this side is all the numbers from experiment A, and on the other side is all the ones from B. And do you notice that, and I'm going to put them the way it would look if you were actually doing it. Do you notice that starting at the middle and going outwards is how you order them? So on the right-hand side is exactly how you'd expect it to be. You see, small to big, right? Small to big, small to big. On the left-hand side, starting at the center, small to big. Starting at the center, small to big. Starting at the center, small to big. So if you don't put them in order, and you don't put them in order from the center going outwards, even although your data is the right data and it's in the right places, WebAssign will say that's not correct. It's not formatted the way it should be. So if you imagine starting at the center, getting bigger, right? Getting bigger this way, starting at the center, getting bigger that way. Okay, little idiosyncrasy, but you kind of need to know it, agreed? Right, now, which, oh, well, they've got the answer. They went and said a new word, and it's called normal. Can you remember symmetric data, right? Single hill. Wasn't it also called, well, can you tell me what was the other name I called it yesterday? Symmetric. Say that again.
Bell-shaped.
Bell-shaped. Guess what? It's also called normal shaped. Normal distributed. So sometimes they'll call it symmetric, sometimes they'll say it's at bell shape, sometimes they'll say it's normal. I think that's actually all of the ones I can think of. Hopefully they haven't got a fourth one that means exactly the same as the other three, but that's all that means. And they're saying it's approximately normal. Well, you gotta be generous, I guess. But when there's only 4 columns, would you agree it's pretty hard to tell what shape it is? I mean, there's not an awful lot of detail to really make up my mind, but they're saying it's approximately normal. And that's not a big deal, because if you get 5 guesses, aren't you eventually going to pick the one that they think it is, even if you disagree with them? So you will get there. Any questions so far? So we've covered a lot of stem and leaf this morning. Here's one where the stem and leaf has been already created. So in this case, the key should have been over here, but they kind of describe what it is. You see that 7 here, that leaf 7, that means the temperature was 67. And you see that 1, that would mean that the temperature was 91, right? So is that kind of obvious? You know, there's nothing really weird going on. So here's the question. Skewed left, skewed right, roughly, or roughly symmetric?
Roughly symmetric.
I would bet that would be the one. Now, if they said to you, what is the highest temperature, wouldn't you simply just look at that one and say 91? And if they said, what was the lowest temperature, wouldn't you pick that guy and call it 63? Would you agree stem and leaf are really good for doing questions like biggest and smallest? And they're pretty good at telling the shape, isn't it? It's roughly symmetric, skewed left or right. They're pretty good at doing those jobs. And then it asks you, what percentage of these 20 cities have a mean August temperature that is in the 80s? Well, if you look at all the ones that are in the 80s, it's those 4 plus that one. And that's 5 of them out of 20. And then turn it into percent. Does that make sense how you would do that? I think that's 25%, but you can check it. We've done that one, so we can forget about it. And we've done that one for sure. I'll let you read these ones, but these ones here are not to do with stem and leaf. These are to do with box plots. This one is a box plot. Oh, let's do this one. You've got a choice. You take your data and you make a box plot, right? Or you take the data and you make it into histograms, right? Explain what features of a data set are best identified using a histogram. So a histogram is better than a box plot for analyzing categorical data. I think that's sensible. A histogram is better than a box plot for looking at individual data values. I don't know, if you group the data like 50 to 60, isn't your histogram kind of loses information? You can't really tell. So I wouldn't say it was good for that, Duke. A histogram is better than a box plot for evaluating shapes. Yeah, I think it would be better. Out of the 5, that's the one I would choose. I'll give you an example of why I would say that. I'm making up a pretend histogram. Would you agree it's pretty easy to tell that's skewed to the right? If I gave you a box plot, you remember those guys? It's not so obvious, is it? So that's why I chose that one. Are we good? Any questions now about stem and leaf before I move on? Right. For check. For the last thing that we're going to do today is we're going to look at histograms and group data. And
Oh, hey, I got a quick question.
yes.
Okay, I'm looking at the stem and leaf, but it has 0011223344, but it has the 40s, has 10s and 100s.
What question number is that you're talking about, Cody?
Number 9.
Number 9. Okay. Got number 9. Right. So what numbers were you saying again?
I'm just confused on where do I place the 10s and where do I place the 100s?
Okay. So you got a number called 10, right? And it's going to belong in one of the 2 zeros, because that's 0 100s and 110. That's where the 10s go, that one. And if you had a 30,
so those 10s then 100s?
Yeah, well, the tens belong as 0, hundreds, and then tens. Suppose it was 50. How would I represent 50 in this stem and leaf? What would I put in one of these two? And which one would I put it in?
I guess the top one, huh?
Well, in here you go 0, 1, 2, 3, 4, and in here you do 5, 6, 7, 8, 9. Now, I'll put in the two ones. Sometimes it's easier when you see the hundreds. Right, 130 goes there. The 1 means hundreds, and the 3 means how many tens you've got. You have 130. And 80 goes here, 180. You're looking puzzled. Are you okay?
Yeah, I don't know. I don't get it.
Okay, let me pause on this one. Imagine we had some data. I'm just randomly picking. Right, there's some data. And we've set up one of these double stem and leaves. And it would look something like this. And the key is that you just pick something at random. 2 / 7 means 270. So this 2, which is one of the numbers in the stem, represents 200. And this digit, so you only use one digit, this, we call that one of the leaves. This represents how many tens you've got. So 207 tens, 70.
Oh,
Right? So if somebody said to me 120, I would either put it here or here. Well, the first one has all the nothing, 1, 2, up to 4s in it. And the second lot has all the 5, 6, 7, 8s up to the 9s in it. So 120 would go here. 102 tens, 120. Right? Now, when you get a number that doesn't have any hundreds, like just 30, which is one of the earlier questions, that would be 0 hundreds and 3 tens and 30. And the next one would be 0 and 40, right? 210 then. Where would the 210 go? Well, it would go either here, 200 and 110, or it would be here, 200 and 110. It's one of the smallers, right? The smallers go first and the bigger ones go second.
okay. Well, let's say you have 21. Where would that go?
Well, 21 has to be rounded off to 20 before you can use it.
Oh,
And if you got 79, you'd have to round it off to 80 before you could use it. So some of the numbers have to be rounded off before you can even put them into the stem and leaf.
okay. So the one that right here says 12, I'd have to round that down.
Yeah, you'd round it down to 10, and 10 would become that guy, 0 hundreds and 110. So it started life as 12, it was rounded off to 10, and then it became 0 hundreds and 110 when we put it in.
Perfect. All right. That makes, thank you.
You're welcome. And you're not the only one. I bet you have helped quite a few other people. So that is good. I like that. Darn it, I forgot what I was doing. Oh, we're doing histograms. That's right. So where am I going with this guy? I'm trying to find them. Here we are. So when you're creating a histogram, it's not uncommon that you have to group your data. So actually, I think this will work better if I show you the data that they've got and just work on it. It's just so much easier, right? There's no reason it's in a grid like this. I guess it just looks pretty. And this represents the number of hours in labour, oh, the poor woman, expected mother experienced at hospital. And that woman got away with, and she won the prize, won her. And that poor woman was there for all day. Not good. So if your mum doesn't like you, it's partly because of this. Right. So although she probably likes you by now. So let's start with something unconnected with histograms, but it's something you need if you want to build a good one. And it's called the range of the data. The range of the data is the difference between the biggest and the smallest. So you find the biggest number and you take away the small one, right? Okay. Now this involves scanning, which I'm not very good at, but I'm pretty sure 1 is the smallest. Can anybody scan through that and tell me the biggest? I think it's 32, but there might be some more in there and I just can't see it.
That's it.
You think it's 32? Okay, great. So 32 take away 1 is called the range. And so 32 take away 1 ends up being 31. Now, that means from the smallest to the biggest, you've got 31. Now, if you want to group data, you can group them in groups of 5, you know, like nothing to 5, 5 to 10, 10 to 15, right? You can group them in groups of 4, right? Nothing to 4, 4 to 8, 8 to 12, and so on, right? So when you group them in different ways, you'll end up with more or less rectangles. Can you imagine if I did a group 0 to 20, 20 to 40, and 40 to 60? I would be lucky if I got 1 or 2 rectangles. And if I tried to do a grouping of 2, I'd end up with 20 rectangles. So we don't want too many rectangles, because all that happens then is that you just get a whole load of 1s and 2s high and a whole load of nothings, right? Not very useful. So there's a kind of sweet point, and the sweet point is around about 6, 7, 8 rectangles. That's a kind of manageable number. That's what you're aiming at, okay? So here is my set of data, and it says here, which of the following is the best option for dividing up the data? So if you divide it into 7 classes, that basically means you divide it into 7 rectangles. Well, let's see if that works. If you make each of them a width of 2, 31 divided by 2, doesn't that get you about 15 or 16 rectangles? So actually that's not right. You'd like 7, right? Or 8 or 6, right? But that one won't do it. How about, would you get 9 if you used 10-hour widths? No. If you use 10-hour widths, wouldn't you get only 3 rectangles, maybe 4? So that one's no good. If you want to divide it into 8, which is a pretty decent number, and you used 4, would that work? Yeah, 31 divided by 4, would that get you about 8 rectangles worth, right? 31 divided by 4 is pretty close to 8. That's the one I would pick. Let's double check the last one. That one could also work, actually, isn't it? 5 or 6. But I think I like that one better, so I'm picking it. So I am now not that they need you to do it for this question, but I want to do it because at least I get to hit the salt button, which is always fun and dangerous. I'm going to hit that salt button. Oh, good, it's over here where I want it to be. Right, there's that data. Okay, wait, it's transferred. Right, that's that data. And I would like to make a histogram, so I'm going to hit charts and graphs. And I'm going to go here and pick hours and labor. And can you see that that's what the histogram looks like? And I'm going to do it, oh God, what was it now? 4. Remember the 4 that they told me? Recalculate it. Yeah. Would you agree that I might have to shrink it a little bit? There. Would you agree that's quite a pleasant looking histogram? You can kind of see a lot in that. Right. Now, if I went and made the bin size, just means how big is an interval, right? So if I made the interval 10, would you agree that's just too cumbersome, right? That's too crunched. If I went the other way and made the interval 20, the other way I should have been doing it too, but that shows you what 20 looks like. Do you see it starts becoming just too, everybody's either the same height or 1, 2, 3 or nothing, right? If I went, that's about the smallest I could go, but if I went 1, it would be even worse than that, wouldn't it? Right? If you look at that, would you agree you can't really tell anything? They're just, right. So if we go for that sweet point, which is round about, say, 4, would you agree that's a kind of nice balance between not having too many rectangles and not having too few, right? And that is, that was that. Now, in this one, you've got a little bit more work to do, but in this set of data, thankfully, SALT's going to do almost all of it for us. Indications of a tree disease have been spotted in a large national forest. Park rangers want to know how widespread the disease is inside the national park, and they use a random cluster sample of 60-acre plots to determine how many trees are in each. So basically, you've got 500,000 acres, and they just pick little square plots, and they probably do it by aerial views. How many of the trees look brown, right? 10, 4, nobody, whatever it might be. And this is what it looks like. Now it says, what's the range of data? God, that's going to be hard for me. I definitely can see a 0. Right now, my candidate for the biggest is 29. Can anybody see bigger than 29? No, okay, so 29 take away 0, the range is 29. Okay. Now, when you look at this interval here, you see them all? How big is the interval? I know they've written it funny, but how many numbers are in each interval? 5, agreed? 20 to 25, 30 to 35. So what that is going to do is it's going to help me get these numbers, and it's going to help me draw this picture. Let's see if we can do it. So I'm going to use SALT again. Wait till the data has kicked in. I'm going to go to charts. I'm going to go select disease. And didn't we decide that it was going to be 5s? Great. Recalculate. Now, the first interval, I don't know if you can see this, but I can. My mouse is hovering over it. It tells me that that's 9. You see that? And then that's 10. That's 9. That's 10. Okay, that's easy to remember. 9, 10, 9, 10, 12, 10. 9, 10, 9, 10, 12, 10. 9, 10, 9, 10, 12, 10. Wasn't that a lot easier than trying to count them all yourself? And then if I bring it back, I may have to shrink this a little bit so we can see it all in one. Right, you see that guy there? That's what the histogram looks like. Keep that in your mind's eye. Oh, where have you gone? There we go. Agree? Now, they could have actually made that a question. Couldn't they have gave you 4 histograms and you had to pick the one that looked like it? But in this case, well, they don't always do every question. 4 choices. Which one fits that picture the best? I've got my answer.
I'd say roughly uniform.
Yes, roughly uniformed.
I like it. Yes, that's what I'm picking. I tell you why I'm not picking bimodal. You know the double hill thing, that's what bimodal is. You might say there's a little bit of a hill here and then there's another bit of a hill here. And so you might look at that and say there's 2 hills. But remember, we have to be pretty generous about this. Don't the things have to be noticeable if it's going to be bimodal? Really normal, big honking hills, right? Not little bumps in the data. Because if you do rectangles, aren't you just going to get a low, a high, a low lots of times? Isn't that just randomly going to happen, right? And that's not necessarily a true hill. So that's why I would go that way. And we are finished with that question. So far, so good. Have we any questions about the histogram so far? less things to do as well, which is helpful, right? Because doesn't salt do all the counting for you, and salt does all the drawing for you. So that makes your life 10 times easier. So let's look at this next question, 15. According to medical researchers who train other medical professions in advanced cardio life support, ACLS, is that like the advanced version of some of you who might be doing first aid? You know, the one where you compress to try and get people who've had a heart attack going into medical. This might be like the nurses' version of that, right? Where they learn more sophisticated techniques. And the following states have given the average life expectancies. I have no idea why they would want to know the life expectancy of these people. What on earth is that telling me? Okay. Well, in Washington State, the average life expectancy is 79.7. And if you're in Utah, it's 80. And if you're in Hawaii, it's 81.5. That's not fair. They get all the good weather and the lovely beaches and the cool food, and they get to live longer than me. That's just not right. You know, if you get a lot of good stuff, shouldn't you die earlier to kind of balance it? Yeah, that's just not fair. Oh well. In the given data, life expectancy is considered to be, I don't think that's a stupid question. I think it's an obvious question, right? Would you agree they are numbers? There's nothing else it could be. Now, it says, use the following stem and leaf. So they actually got this data and they made this stem and leaf out of it. So let's see what we have. We have a stem is 76 and a 6. Oh, I know what that means. Doesn't that mean 77.6? Do you see how it's been created? And so, is the key that the leaves represent which of the following? So the leaves is the 6, right? Or the 9. Is that tens, ones? Does it represent tenths or does it represent hundreds? What does that 6 represent?
Tenths.
Tenths, right? So I better put the dot in the right place. Determine whether the following statement is true or false. From the stem and leaf that I can see here, we can see that less than 29% of the life expectancies in the Western United States are aged 80 or older. %. So 80 or over. Let's see how many of these are 80 or over. That one, and evidently that one. This is what they're called Western United States. So that's 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 out of 11.
False.
Did I miss one?
No, it's false.
Oh,
It's 27.2%.
yeah, 27.2, and they said it was that one. So we're going for false.
Wouldn't it be true if it's less than 29%?
Oh, less than, oh, yep.
Yep, I now changed my mind. Yes. Moral of that story, shouldn't you read the question carefully?
Heston, yeah.
Yeah, I did the same. Okay. We have some data here, which is the A's and the B's, right? So we've kind of covered that one earlier, so I don't need to do that one. Here is our last, at least the last question here, and that's perfect timing. You are looking at a box plot, right? Already made for you. This is a biology student is studying the growth of those bacteria from earlier, I guess. After 2 days, the student counted how many colonies. So one of the Petri dishes had 5. One of them only had 1, the one that you gave it at the start, I guess. And one of them was ready to take over the world because it's got 14 in it. So this is from that data, this is the stem and leaf that was corrected, right? This is box plot, I should say. Determine whether the following statement is true or false. The box plot correctly shows that there are no outliers. Yes, I don't see any outliers. Do you see any outliers? Silly question, okay. Which of the following args, one of those things, which of the following is not true? Well, let's look at it. The first one they say is the range is 8. Well, if you start at 1 and you finish at 14, shouldn't the range be 13 then? And well, guess what? I found it the first time, right? Oh, wait a minute. Read the question carefully. Could there be 2 or 3 wrong answers? I found one, but could there be another one? The way that's phrased, could there be a second wrong answer? It says which of the following. If it said which one of the following, wouldn't it stop? Right? So let's try the next one. The IQR for the distribution is 3 colonies. Well, the interquartile range is the difference between Q1 and Q3. That's what an IQR is. So if you take the third quartile, which is 10, and subtract the first quartile, which is 7, you do get 3. The mean is greater than the median. I don't know, but I could find out. Couldn't you add them all up and divide by how many and then compare it to 8? My gut feeling is that that's true, although I'd have to check it. And the last one is the median is 8, and that is correct. So I only found one wrong. Right. I haven't really checked that the mean is greater than the median, but couldn't I do it in my calculator? And my gut feeling it is. So since that is the last one, I'm going to do a key, and I'm going to see if I guess right. Am I good or am I good? Oh, no, I'm not. Do you see one of my answers is wrong?
Yeah, because isn't it 10 to 14? That would be an outlier, right?
Yeah.
14.
I mean, I guess that's what they're saying. If you look at this data, you've got a 10 and then nothing happens till you get a 14. I know there's 2 of them, but that doesn't really change matters. So they have said that you can't tell that there's an outlier in the way this picture was drawn. But can't we rely on that there's 5 guesses? So if it says it's wrong, you know the other one's right. So it's not really going to be a big deal. 10 to 14. Yeah. I'm not 100% sure that there's a big enough gap between 10 and 14. I mean, it's big, but is it like massive? 10 and 20? Yeah, right? I would definitely think if it was 10 and then the next number was 20, right? I'd definitely be saying outlier then. But, that's outliers are very often until we tell you how to not.
Or are they talking from the 1 to the 7? Oh, but there's 5.
No, there's
Yeah,
other
the 1 to 5 is also a difference of 4.
4, so it's no worse than the other side. Yeah.
For sure.
We could argue on that one. They say it is, I say it's not really, or I don't think it is. Won't you be glad once I tell you how you do the test so that nobody argues? But right now we're arguing because we can. Before we go, make sure that you type in your last names, and while you're doing that, I want to set up something just to remind you what's happening this weekend. So last name only for attendance, please. Hopefully you're doing that as we speak. And I'm now going to go in and show you what's going on. You have 3 sections to do for this Sunday, and that's your homework assignments, and we've just finished that one, so you should be good. You've got your test, which should be done by midnight Sunday. That little mark there is telling you how long you've got, right? So make sure that when you're doing your test, that whenever you click on it, that you start doing it right away. It's not like homework. You could go and come back in half an hour and do another question, right? It's like a set fixed time. Homework, on and off, come in and go away as often as you want. Won't make one darn bit of difference, right? You can do it 10 times if you like. If you, for some reason, do not have enough time to finish your homework, you can ask for an extension. You just email me saying, can I have an extension? And I'll give you extra time. But if you do that, you will lose your bonus participation point that you get. So you may want to decide, do I want to keep that bonus participation point, or do I want more time to do the homework? Tests do not get extended. So at midnight, if you've half done it or you haven't done it at all, that's going to be probably one of the 2 ones that we throw away. And so it won't affect your grade as long as it only happens twice.